Okay, let's dive right into a question that sounds like it's straight out of a science fiction. What if one of the most sacred artifacts from the ancient world isn't just a relic, but a blueprint for some of the most advanced, mind-bending physics we know today? We're talking about the High Priest's breastplate from the Bible. This ornate, jewel-encrusted garment. For thousands of years, it's been seen as a religious symbol. But what if we've been missing the point? What if it's not just an ornament, but an instruction manual? One written in a language we're only just now learning to read, the language of chemistry. So a research program started with this completely wild idea. They decided to treat the 12 gemstones on the breastplate not as pretty symbols, but as a specific set of chemical instructions. The whole point wasn't to go looking for a specific answer, but to see if any kind of coherent signal, any pattern at all, would emerge if you put the data under just immense analytical pressure. Right, so step one was just getting the basic facts down. They mapped the 12 stones in their biblical 4x3 grid to their most likely real-world minerals. And what's so important here is that this is not just a random collection of gems. You can see right away there's a structure. You've got your silica-based stones like carnelian, but then you've got these outliers, these special instructions, like turquoise with its unique copper formula, or zircon, which sneaks in the element zirconium. Suddenly, the ancient artifact becomes a structured chemical database, ready to be analyzed. Okay, so you've got the chemical data. Now for the really hard part. How do you find a real, hidden signal in all that noise without just, seeing what you want to see? To get around that, the researchers came up with a super rigorous method they called compression. The whole idea behind compression is actually pretty simple, but it's also absolutely ruthless. Think of it like this. Any theory or pattern they tested was only allowed to survive if it made the whole thing more precise, more specific. If an idea just made the signal fuzzier or created a bunch of new possibilities, it was immediately thrown out. The bet was that if there was a real signal hidden in there, this pressure would make it sharper and clearer, while any random coincidence would just fall apart and dissolve into static. It's a system designed to kill wishful thinking. So they ran the analysis, they applied this compression method over and over again. They ran it through multiple tests, making it harder each time. They even actively tried to break it, to prove it wrong. But through all of that, one signal just refused to go away. In fact, under all that pressure, it only got stronger. And this is what emerged from that whole process. By treating that ancient grid of stones as a set of chemical rules, the analysis kept converging on one single, unmistakable answer: a specific uranium-beryllium compound, UB13, and a specific version of it where you swap out a little bit of the uranium for thorium. Now get this, this wasn't one of many possible answers. It was the only coherent chemical blueprint that survived the entire gauntlet. So what in the world is this stuff? Well, UB13 is a Heavy-Fermion superconductor. And trust me, these things are at the bleeding edge of physics. They're these incredibly exotic materials where, at super cold temperatures, the electrons moving through them act like they're hundreds of times heavier than they should be. This leads to all sorts of bizarre and powerful quantum behaviors, like conducting electricity with zero resistance. We are not talking about some common material here. This is a major puzzle piece in modern physics. And here's where it gets absolutely wild. The program didn't just point to a material. It pointed to a mystery, a very famous one. See, when you add a tiny bit of thorium to UB13, the material does this weird double transition as it becomes a superconductor. Physicists have been scratching their heads over this for more than 40 years. So the breastplate didn't just spit out a chemical formula. It pointed directly at a known, famous, and completely unsolved problem in science. Finding that result was already pretty mind-blowing. But the research didn't stop there. Because once you've found a hidden structure like this, you can then use it to do something totally new. You can ask it to make a prediction, to see what else this ancient blueprint might be pointing us toward. So they build this computational engine, Atlas RB13, to basically explore the entire family of related materials. It autonomously sifted through 171 different possibilities. And what's so cool is that the first thing the engine did was correctly flag the known thorium puzzle as a key point of interest, which tells you it's on the right track. But then, it ranked a completely new, never-before-studied material as the #1 top priority target for scientists to actually create in a lab. And here it is. The new material is a version where you replace some of the uranium with thulium. The researchers have given it a proposed name, Thummite. This wasn't some random guess out of a hat. This was the top-ranked, highest potential new discovery predicted by the very same logic extracted from the breastplate structure. Now, this is where it gets really exciting for the future of technology. Thulium is nothing like thorium. As you can see here, thorium is non-magnetic. It basically just waters down the original material. But thulium? Thulium is powerfully magnetic. So when you put it into the mix, you're not just tweaking the system. You are literally starting a war inside the material, a direct battle between two of the most powerful forces in the quantum world, superconductivity and magnetism. The whole game just changed. So why should we care about this little internal war? Well, because that domain wall, the literal boundary line where magnetism and superconductivity are fighting it out, that's the exact theoretical environment where scientists believe one of the holy grails of physics could pop into existence, Majorana particles. These are unbelievably weird particles that are also their own antiparticles. And they are thought to be the secret ingredient, the key building block for making quantum computers that are actually stable and don't fail all the time. If Thummite works, it could be a material that just naturally cooks up these particles. That's not a small step. That's a potential giant leap for humanity's computing power. Okay, so let's just take a step back for a second. We have a 3,000-year-old artifact that seems to point to a 40-year-old physics puzzle, which in turn points toward a next-generation quantum material. This raises some seriously deep questions that go way beyond a physics lab. What on earth could this all mean? So first things first, and the researcher is very clear about this. This analysis does not and cannot prove that ancient priests knew a thing about quantum mechanics. Let's be really clear about that. The claim is about structure. It establishes that a complex, non-random, and verifiable pattern exists inside the artifact's chemical makeup. Why it's there, well, that's a whole other question. So if it's not a literal instruction manual from the past, what could it be? One philosophical take is to think of it as a compressed sanctuary sign. It's like a zip file. It's a tiny object that manages to store all the ordered information and identity that a massive temple would otherwise make visible on a grand scale. And this leads us to a truly mind-bending possibility. For thousands of years, the idea of rebuilding a third temple has been about a physical building made of stone and mortar. But what if this discovery hints at something else entirely? If a small ancient object can hold this much ordered, recoverable knowledge, could it be that the real temple isn't a building at all, but a structure of information, a body of knowledge that needs to be preserved, understood, and built upon? Ultimately, what this whole thing does is give us a brand new way to look at our own past. It suggests that maybe, just maybe, some ancient objects aren't just symbols for us to interpret, but are actually structured bundles of data, just waiting for the right tool to come along to decode them. And that leaves us with this one final, really tantalizing thought. If a message this sophisticated could be hiding right in front of us for 3,000 years, what else have we been looking at but not really seeing?